question 510 in order successor in binary search tree. Given a node in a binary search tree, return the in order successor of that node in the binary search tree. If the node has no in order successor, return null. So what is the successor? The successor of a node is the node with the smallest key greater than the node.val. So let's go through some example. As you see in this example, this is the binary tree that we have, and we want to find the in order successor of node 1 here. So a node like bigger than the smallest node bigger than 1 is 2, and this is what we are going to return. And if we want to find the in order successor of node 2, we are going to return 3. And for the in order successor of 3, we are going to return null because there is no node with value bigger than 3. In this example, we are going to find the in order successor of node 6, and as you see, there is no node with value bigger than 6, and we are going to return null. But if we were looking for the in order successor of node 1, 2 was the answer. We are not going to return 3 or 5. These are bigger than 1, but we are going to find the smallest value bigger than the node that we are looking for the in order successor of. And let's look at a binary search, a bigger one. I got this binary search tree from a website called cs.usfca.edu that you can like make your own binary tree and you can play around with it, which I think is pretty cool. So in this binary tree, what we know, what is the property of a binary tree? When we have a node, all the nodes at the right side are smaller than the value that we have in this node, and all the nodes on the left side are smaller and on the right side are bigger, right? So if I want to find the in order successor of 50 here, I go to the right because I know the right nodes are bigger. So we have 70, 80, 60. Which one should I return? For the in order successor, we find the smallest value that is bigger than the node that we are looking to find in order successor of. So here it's going to be 50. But how can we get here? What we are going to do, for every single node that we want to find the in order successor, we check if that node has right nodes, right? So if it has right nodes, we go to the right, and then we check if it has left nodes. One step we go to the right and we check if there are if that node has left child, and we go all the way down to the most left child to find the in order successor. So how does that work? We go one step to the right. If there is no left child, we're just going to return that, and if there is a left child, we go all the way to the down. So let's write that down. So we're going to say, if the node that we are looking to find the in order successor of has a right child, what we are going to do, we are going to go one step to the right. That's it. This is the first step, right? And then we check if that node, the updated node, has left child. If it has left child, what we are going to do, we are going to update the node to the most left child, and we keep doing this loop until we get to the most left child. And at the end, we are going to return the node. So if there is no left child, we are going to just go to the right and return that node. And if there is a left child, we go all the way to the most left child and return that node. But what if we don't have a right node? Let's say we didn't have this part. What would we do? We check, or like something like this. Let's say it's 30 and we don't have the right child here. What we do, we check if there is a parent. And if there is a parent, then we check if the value that the parent has is smaller than this value. And if it is, we are going to go to the next parent. And if it is not, we are going to return the parent. So what we are going to do, it's like we say while node.parent. So if the node has a parent, right? So it's not a root node, so it has a parent. And the value of the parent is smaller than node.val, we need to go to the next parent. I'm gonna show it to you so you can better understand. And at the end, we are going to return node.parent, right? So what I mean by that, let's say we have 10 here, right? And let's say we don't have 15. Let me remove 15, delete. Oh, let's remove 15. The cool thing about this chart is like you can remove numbers. Okay, let's see. So now let's say we have node 8. When I remove 15, it changed the... Okay, so let's find another example that we don't have a right child. Here, I think. Okay, 7. We are going to find the in-order successor of 7. So 7 doesn't have a right child. So what we should check is we should see if it has a parent, and if the parent's number is bigger than 7. I check 7. 7 has a parent, and the value is 6. 6 is smaller than 7. What we need to do, we need to go to the next parent. So if we go here, we check 4. 4 is still smaller than 7. So we go to the next parent. So we have 8 here. 8 is bigger than 7. So this is what we are going to return. So this is the case for when the node value is bigger than the parent value. And what is important here is like by default the parent has none. So if we are if the case is a root node, we are going to return node.parent, which is going to be none. So the time complexity, the average time complexity for this solution is going to be log n, logarithmic, and the space complexity is constant. Thank you.